हमने कॉल किया था। Hello participants, this is Manas Kundu, Asia Power Quality Initiative Coordinator. Good afternoon and good evening. It's my pleasure to welcome you today to our second webinar of 2016-17. Earlier, we hosted webinar on various topics. APQI, or the Asia Power Quality Initiative, is an independent platform that aims to build awareness and capacities on issues related to power quality. This pan-Asian platform, supported by national support network partners, continues to carry out activities towards capacity building and awareness creation amongst various stakeholders. We work further to facilitate regulatory and standards initiative in respective country. We provide a neutral platform for exchange of knowledge and best practices concerning our quality. Our website www.apqi.org, supported by Leonardo Energy Europe, is the single largest resource for discussion papers, research and data on power quality in all the countries that we work. We work with a focus on shared learning, transparent exchange of information, and active engagement in the field. In increasingly digital world of today, the sensitivity of plants, process, and equipment demand for high power quality environment. And poor power quality can only impact severely both in terms of economics and safety. Power quality in the low voltage and medium voltage network and end user premises is largely not measured and unscientifically is not well understood. Hence, power quality measurement and verification at each end is very much necessary to understand the actual power quality event and causes of power quality problems, and thereafter designing effective countermeasures. Now, the economic analysis of any new or transformation project is the fundamental step for any investment decision. And this holds true when addressing the increasing power quality issues in industrial and electricity distribution networks. It is utmost important now that utilities and customers adopt and evaluate the financial aspect of power quality and perform cost-benefit analysis of different solutions before making the investment decision. This webinar brings experts representing the perspectives of the utility and the technology provider to share their experience on the topics like key challenges and importance of utilities investment analysis for PQ solutions, innovative technologies in PQ mitigation and their viability for end users. Keeping above in mind, I welcome you all on behalf of APQI India to this webinar uncovering investment analysis for power quality solutions. Today, our distinguished industry and utility experts are from Reliance Infrastructure and Moher Group. They will share their thoughts on above issues with us. Mr. Rajiv Saraf, keeps his mantra quite simple and befitting. Information technology must go to business instead of business coming to information technology. Mr. Sharaf brings with him more than 2 decades insight into the fields of telecom, broadcast, and IT infrastructure, and was recently elevated as CIO of Reliance Infrastructure. Here, he leads the company's business initiative to participate as an IT consultant and IT implementation agency under RAPTIP program of Ministry of Power. Starting his career in 1988 as a scientist in the Space Application Center at Ahmedabad, Mr. Sharaf worked closely with many other organizations, namely Gujarat Communication Electronics, Department of Telecom, Indian Railways, Doordarshan, BSES, and Mumbai Discom. Our other expert is an accomplished Mr. Mustafa Wajid, an engineer, entrepreneur, leads the technology-driven Meher Group as its MD and Chief Executive Officer. Over the last 3 decades, he has led the Meher team to build leadership positions in various businesses like reactive power compensation and systems for T&D networks, power quality solutions for LV network, and passive components for power electronics and advanced dielectric material. Mr. Mustafa has been a long-standing IEEE member, serving on several committees of organizations belonging to Government of India. He is in the IEC TC33 and SG4, as well as chair of several national and international technology conferences. He has been a mentor, member, executive council of IMA for several years, and he is the key driver for Engineer Infinite program, which is focused on strengthening industry academia engagement. He also chairs the IEEE's LVDC Forum India and is a member of IEEE ICCOM, which is part of the IEEE South Asia Standards Board. I sincerely hope that you will experience a good discussion in today's session and look forward to your active participation in future too on this platform. Please do participate in the survey on APQI ORG. Before I finish, just few housekeeping things. We'll have 2 presentations by experts, one after the another, for 30 minutes each. During this, we'll all be muted, and kindly keep your questions noted so that after both the presentations are over, we'll have a question and answer session during which you can put on the questions to get expert views. Later on, we'll also host the presentations and the question answers on APQI website, which you will be able to look at and access at your free time. Thank you. With that, I now invite Mr. Sharaf to take over.
Good afternoon and good evening to everybody. I'm Rajiv Sharaf. I'm taking care of IT and new initiatives related to innovation in Reliance Infrastructure. And we are into the business of power distribution, power transmission, power generation, construction of the power plants, construction of the road business, operation of the roads, construction of the metro, operation of the metro, and cement. It's my pleasure to be part of this seminar today to explain what are the challenges we have faced, what initiatives we are taking as a part of distribution to improve the power quality, improve the customer service, improve the customer satisfaction, meet the regulatory requirements. The power distribution, if you really look at in last 10 years in India, the last 10 years were majorly spent on the telecom revolution. But in last 2 to 3 years, a lot of thrust is happening on the power distribution and power, specifically the power sector. Every day new technologies coming up, government is also driving with a lot of initiatives to ensure that the transparency, customer service, our quality, and theft, losses, everything is reduced. If you really look at the power distribution industry is not confined to a small territory. Their entire assets are spread across the boundary, across the geography. And the biggest problem is how to monitor the assets, how to control the assets, how to ensure that all the assets are timely managed and maintained. Second thing, majority of the work involved is related to blue collar. You will find a lot of people going into the field, doing repair work, doing the excavation work. So it's majority of the blue collar job. There is hardly any white collar job. Network is old. Like after Edison discovered the bulb, hardly any changes happened. The transformers are there, but whatever transformers were built before decades are still continuing. Network is very old. You can't change the network overnight, because if you try to change the network, there will be disruption. So, and at the same time, the network is not in position to take care of the current load. So you have to go on expanding the network. Huge transmission and distribution loss because of the poor network. There is a huge demand against the supply. There is a mismatch. There is a power requirement curve is not flat. And if you really look at, the power is taken for the granted. If you switch on the electricity and if it is not working, then people start understanding the power is not there. If you really look at the power quality, what happens, the power is being paid, used by the industry. The industry, when start using the power, they generate lot of harmonics, lot of surge, and this harmonics goes on penetrating through the power cable, and then ultimately consumes the power, and ultimately it results into the I square R losses. It reduces the power carrying capacity of the cable, ultimately affecting low voltage at the other end of the cable. This also results into the frequent power outages and load imbalances. What is actually needed? If you really look at the utility industry has been implementing SCADA, that is supervisory control and data acquisition system. They have been implementing distribution management system. IT was implementing purely IT systems. But due to convergence of IT and OT, because of new technology available, because of analytics available, because of the converged communication available, hyper connectivity, cloud computing, there is a need of IT and OT both to get integrated. We should use the mobile technology for the better workforce management, so that we know where are the people, what is happening at the assets, we can monitor everything, we can control the thing, and in real time give the information to the customer. The biggest challenge is the utility are working on their ARR model, which is purely based on the capex, wherein based on the capex the ARR is calculated, and as it requires a huge capex, it straightway impacts the tariff, and as it impacts the tariff, the new initiatives, new modernization activities are somehow getting delayed or getting deferred or are taken over a longer period. Second is, even if we do automation, there is requirement of specific small sensors like fault passage indicators, which if you really use it, then immediately you can identify where is the fault and really reduce the turnaround time. What we practice, as I rightly said, there is a voltage harmonic which is generated by the high voltage load, and that creates various voltage sags and interruption. To take care of this, we have implemented automatic power factor correction control module, which has got power capacitor bank of 12 number of capacitor, which are kept at each and every substation. Substation means a distribution transformer, which depending upon the quality of the power, depending upon the reactive load, adjust it the capacitor and tries to control the power factor towards unity. We are also trying to put up the injector at the source point, that the distribution transformer point, to mitigate the impact of the harmonics. We measure the parameter name is SAIDI, SAIFI, and KAIDI, which is known as supply availability index and supply availability frequency index. This we measure to benchmark our performance. I'm trying to show what are the SAIDI, SAIFI parameters. In this screen, you can see there are we had a SAIDI of 4 minutes in the month of April, in the May 9 minutes, in the month June 9 minutes. It is basically number of customer affected, time to restore the no supply complaint, and what are the total number of customer. It's a ratio of all this. Same way, it also measures the power quality. What is the frequency of interruption? One is what is the duration to repair, there is MTTR. Another is how frequently the power is going, that is measured by SAIFI. And if we take ratio of both this, then we call KID. And if you see, I have tried to benchmark this with respect to various utilities in India, and we are meeting or even better than the other performance factors. The key driving factor in the today's age of IoT is put up various sensors at various network segments, try to get the details using various technology, which is Bluetooth, or you talk of Wi-Fi, or you try to talk of RF, think of mesh network, and try to get all the data in the real time into the system. Use GIS information system so that you can exactly know the status of entire network in the real time, and then take corrective action to mitigate the risk, address the problem, and realize the better customer service. I'm on the slide number 9, which talks of how the entire network is getting integrated and how we are working on this. If we really look at, my first opening statement, I mentioned that the biggest problem for the utility is to see the network, to have the visibility of the network. By using GIS and by using various technology, we are in the position to see the entire network sitting in one room. By click of the button, I can see what is happening on my network, where is the fault, where is my user, where is my vehicle, whether there is a fault, should I in position to send the components or spares required in the real time or in a more optimized way by using vehicle tracking system and workforce management system, depending upon the load requirement and availability of the supply. Can I try to identify which is the area which I should try to shut down so that my customers are less affected, and at the same time the important customer where the power quality is very important, wherein like industries or hospitals or emergency locations or airports, those should not be switched off. Everything is planned looking at this automation landscape. Important point is surveillance of the network, because the network is scattered, you don't know what is happening to your network. So we have put up the cameras. The cameras are triggered as and when there is any deviation happening, any intrusion happening in our premises, and then in the real time the crew is mobilized to go to the site and ensure that there is no damage to the network, because that is very important with respect to security of the grid. I'm on the slide number 10. We have in our network we have got ring main units. You have got primary network, like telecom network, you have got a primary network, you have got secondary network. Same way in the electric network, we have installed RMU and made the entire secondary network in a ring fashion, so that as and when there is no supply available, we immediately switch over to the alternate path, and that everything is happens sitting in the center control room. We have introduced neutral ground at individual LT pillar, so that whatever harmonics or whatever voltage deviations are observed, everything gets grounded at that point rather than having the ground at the substation level. We measure the load balance, that is RYB. If there is a total imbalance within the load, then we try to segregate the load so as to have the balancing load. And important aspect is how do you make your stakeholders, your customers aware about the power quality. We brief them, we create sessions like young energy savers, because children are the best ambassador. They go and tell their parents that we should start saving the electricity, and they also participate, they also do the uh, awareness session within their building. They become very good ambassador for this scheme, like LED, where we try to reduce the power utilization, then replacement of the old equipments with the more energy compliant equipments. This type of awareness programs, we do it from the consumer side, so that ultimate load on the grid is reduced, the quality is maintained, and we provide a better quality service to the customers. In totality, with increasing pace of the modernization and availability of the technology, usage of the electricity, and more demanding customer, there is a need to have a proper quality control, good quality of the electricity to be supplied to the customer, and that is possible provided utility with the stakeholders and customer together and implement the system so that the losses are reduced and the utility is not required to invest huge capex, which ultimately burdens the customers. Thank you.
Should I start? Manus, are you there? Manus, are you there?
Shobhaji, please start. Yeah, I am there. Please start.
Yeah, so can I go ahead?
Yes, please go ahead.
Yeah, namaste everybody. My name is Mustafa Wajid and I'm an electrical engineer. Today's topic was highlighted as uncovering investment analysis for power quality solutions. We will now start a short presentation on some of the issues, some of the major issues involved in this domain. And one more. To begin with, let us identify what we mean by power quality issues. I'd like to just remind everybody that we are today discussing what we call steady state phenomena, and we are not covering anything to do with any transient phenomena that may occur. Number one. Number two is that if we look at the power quality issues, let us start with voltage. Sorry, before that, I'd like to also qualify that my presentation is more oriented towards looking inside the installation, that is, after the utility power is handed over to the consumer. Having said that, let us start with voltage. There are several different issues of voltage. Some of them are well understood, some of them are not so well understood because they also occur in very rare cases. But there is also one which is not given enough importance, and so I will go one by one. And in voltage, we have over voltage, under voltage, what we call voltage dip. Some people like to call it voltage sag, so I have put it as dip/sag. Then you have voltage swells. You have voltage flicker, which can occur in certain situations. You have voltage surges, which can occur because of another set of circumstances. And very importantly, I introduce the issue of voltage unbalance, which is becoming more and more of a problem for a variety of reasons. Now, we need to understand that when we say voltage, it's not just one or two dimensions, but it is a total of all these things that need to be looked at when we are understanding what we want to do with the power quality issue. The other second issue is frequency. This is relatively less of a problem, but we need to tick the box and verify that we are comfortable and we are safe. Generally speaking, frequencies in overloaded networks or optimally loaded networks will be 50 hertz in our country, or maybe slightly lower. In underloaded networks, it is possible that it can go slightly above 50 hertz. That's a phenomena which has been noticed, for example, in some parts of the country when large power plants are commissioned and the demand is actually lower than the supply capability. We then have the third bullet point, which is power factor. And in power factor, we have to remember that there are two different types that we can talk about. One is the displacement power factor, which is the angle between the fundamental voltage and the fundamental current, and the true RMS power factor, which is the angle between the RMS voltage and the RMS current. Now, these two are very different things. They mean very different things. So we will come to the, more technical issues a little later. The fourth issue is harmonic distortion, primarily voltage and current distortion. Of course, we could also go down into looking at demand distortion and so on, but those are derived from these two. So fundamentally, it's voltage and current distortion. This basically means that the sine wave that we believe should be there is no longer a pure sine wave, but it is distorted because of a variety of factors. In other words, non-sinusoidal content is there, or has the sinusoidal wave has become partly non-sinusoidal because of various contamination or corruption, as we can call it, due to higher frequency components which are conducted disturbances. We then have the issue of neutral current. And traditionally, we all well-known fact that if there is an unbalance in the system, the resultant current will flow in the neutral. But there is another problem that has emerged, particularly in the last 10 to 15 years, where the IT companies, the primary loads are in the form of SMPS loads, which are servers, and these generate particularly triplen harmonics. Triplen harmonics are those which are multiple of 3, but which are not even numbers. So, for example, the third harmonic is triplen, the sixth harmonic is not a triplen harmonic, whereas the ninth harmonic is again triplen. Now, these triplen harmonics that are generated by the IT data center type of loads can be almost equal to the phase current. And mathematically, all these triplen harmonics add up in the neutral, and therefore it is possible that the neutral current can become similar to the phase current, or in many cases even exceed the phase current. So we have to be a little careful and manage this properly. With regard to the neutral, another important aspect is the neutral to earth voltage, because in many protection systems and in many sophisticated systems, this value has to be below a certain level, and if it is not there below that level, it can create negative side effects for the whole system. Having said this, I again repeat, voltage with several dimensions to it. over voltage, under voltage, dip, sag, swell, flicker, surge, and unbalance, which makes it a total of 7 different items under voltage. Frequency variations, power factor, we have 2 issues to worry about. Under harmonic distortion, we have primarily 2 issues to look at. We can derive several other numbers which are also important. And in neutral related matters, we have both the neutral current and the neutral to earth voltage. Now, these are the broad issues that will arise in any installation. All of them will not arise in any given installation. Some combination of factors will be there by which some will not arise in certain types of installation. For example, a steel plant will have a very different type of issues, whereas compared to an automobile industry, which is compared to an airport, which is compared to, let us say, a hospital, or a big commercial building which is housing a large number of offices and so on and so forth. Similarly, the IT loads are very different. So all of these factors will not occur in all, but there can be a combination of any of these which can occur depending on the type of load and the type of installation and the network that one has. With this, we now go to the next slide, number 3. What are the real world implications of power quality issues? I categorize them into 3 primary categories. One is economic. There can be cost benefits, there can be financial benefits arising from better power quality management, and these are classified as economic issues. The second is compliance issues. It is necessary that we create a situation in the network that all the power quality are within the compliance limits of what we require within our installation at the point of common coupling with the utility, and keeping in mind sensitive loads in our within our network which may require additional factors to be considered to ensure compliance. I have not used the word statutory compliance because this compliance is an overall compliance issue and not just a statutory matter. It is also a technical compliance, it is also a utility compliance, it's also a network compliance. The third is, and we have seen a lot of this category in our experiences, for want of a better word, I call it collateral damage. Power quality can result in all kinds of things. Some of them are well known. For example, large motors can fail, resonance can happen, current amplification can happen to such an extent that bus ducts can melt. But today, one of the things which is not given enough importance is in modern networks, there is a high level of digital control and automation, as well as web connectivity or internet connectivity. Power quality problems can create operational problems, malfunctioning, failures, etc. in different types of these kind of sensitive pieces of equipment and systems in today's modern network. The other thing that we need to remember when we are dealing with real world implications of power quality is that the power quality issues are by their very nature completely dynamic. They get affected by factors that are beyond the control of the owner of the installation. You can have increased distortion coming in from your supply system next year as compared to this year. You can go on changing some load in the network and alter your power quality characteristics when compared to, let us say, 1 year ago. It is therefore very important that vigilance must be maintained. And today, vigilance has become easy to do or much easier to do because of the technologies available both in terms of control, sensing, measurement, IoT, etc., etc. It is possible today to see power quality parameters on an app on your mobile phone in many cases. And vigilance is not only a technology issue, vigilance must be a systemic issue where at one level you monitor what's going on, at another level you actually take corrective action and enforcement. And that is why I use the word vigilance, because it just doesn't stop at spotting the problem. The problem has to be managed and controlled to the satisfaction of all the compliance as well as other matters. How do we therefore deal with these real world implications? Because we now are talking about investment in power quality, and how do we make those decisions based on certain logical approaches? So what should be our strategy for investment? That was what I thought I was expected to focus upon in this presentation. I have categorized the strategy in multiple steps, in different steps. And now we are on slide number 4, just to repeat in case people have not shifted to or not able to see, kindly alert the organizer. Step 1 is that a thorough technical analysis to identify the specific power quality issues must be done. Now when I say specific, there is a whole menu of power quality issues. Now all that menu may not be applicable to a particular installation. So a technical analysis needs to be done as to which of the items in that menu are likely to exist and likely to create difficulties. It is thereafter necessary that particular solutions to achieve the economic benefits and compliance may be evaluated. Let's say we want to improve power factor, we want to reduce harmonic distortion. We want to have a situation, we have some sensitive load where the voltage fluctuation from the grid is not acceptable, and therefore we don't want a galvanic connection. That means it should not come through a transformer supply, but we want to isolate it from such galvanic connection. So therefore we will put a double conversion UPS, and therefore ensure that there is no connection between the supply in terms of waveform and amplitude of the voltage from the supply side to the load side. So these are different solutions that can be contemplated. There are a lot of companies out there who will be happy to do this analysis and recommend a different set of solutions. There are also independent technical consultants and experts who, as a user or as a customer, you are in a position to contract with them to evaluate what these third-party solutions are, and are they really suitable, and if not, what should be the correct approach. Now, once we are at this stage, we can define the investments needed to implement these and freeze them, because we can't decide we can't take a final decision yet, and then freeze it to be taken up later as a business decision. Having said this, we now move to step number 2, and that is, what do you do to avoid collateral damage? Now this is a little complicated subject. It may not be possible for typical power quality solution providers to understand all the dimensions of this, particularly in very sensitive installations. It requires expert study to identify the vulnerable areas. Now this expert study need not be from a power quality expert, it could be from an equipment expert. Let us say in a hospital I am installing a very sophisticated CT scan machine, most advanced, etc., etc. Now it may require that the voltage, the frequency, the neutral to earth voltage, the total harmonic distortion of the supply is maintained within a certain level. Now it is important that the user of that equipment understands this from an expert and ensures that his electrical engineering design of the network is made in such a way that those parameters can be achieved. So these require different types of experts depending on the vulnerable areas, and solutions can then be identified to mitigate the risk of any possible collateral damage. Now the investments needed and the time frame over which they may be phased out, because that is also going to be an issue in these kind of matters, will then become quite clear. This is a bit of an involved process, but unfortunately there is no shorter way of doing it. My caution to everybody here is that this cannot be looked upon purely as a economic investment. Avoiding collateral damage is like an insurance investment. So when you buy insurance, you don't talk about payback periods. You take it because you want to protect yourself against any kind of risk, any kind of mishap, accident, etc., etc. So this part of the power quality investment cannot be justified in purely financial terms. It has to be considered like an insurance investment. This is as far as step 2 is concerned. We are now on slide 5. We will move to slide number 6. Having done the step 1 and step 2, it is important to take a holistic overview of step 1 and step 2 together, and only then conclusions can be done by a group. The considerations are different, the issues involved are different, the people involved are different. Now, the overall investment package for the power quality improvement must be then reviewed, and investments to achieve economic benefits and compliance can be a typical business decision. We could talk about internal rate of return, payback periods, etc., etc. And investment to avoid collateral damage should probably be done better simultaneously. Having said this, we will move to slide number 7, which is the last slide of my particular presentation. We have seen in our experience that while all the theoretical stuff sometimes is done quite well, efficient execution is not necessarily done always. And this is a must, because whatever theoretical assumptions we have made in the design stage, in the evaluation stage, they have to be reflected on the ground through efficient execution. And what we find is that while a lot of importance is given to execution of the overall electrical installation, or the overall, I would say, project management of the power management scenario within the network, power quality is not treated as an independent vertical, and therefore my recommendation is that the project management techniques as applied in other areas must also be applied for power quality solutions as well. Now, we all said that we are aware that power quality is a dynamic variable. Now, this is the 4th step, and this is very critical, because post-execution monitoring is extremely critical, because it gives you an idea of how the ground reality is changing, and sometimes assumptions may not necessarily be valid forever. Things can change after 6 months or 1 year. So therefore, we need to do periodic reviews of the power quality situation. My strong recommendation is to develop an MIS format, which I have advised, and in my experience, many people who have worked with us or who have been our customers have used it. And to do a periodic review based on an MIS and initiate corrective actions to be implemented in a timely manner. This is unfortunately a difficult matter. We cannot change the fact that power quality varies dynamically. It's a function of what is happening on the utility system. It's a function of what is happening inside your network. It's a function of how well the execution and management of the power quality solutions are done. We have seen cases where harmonic amplification has happened, but because somebody did not want to switch off the equipment, they went on increasing the fuse rating, because every earlier smaller fuse rating was blowing. So finally they came to such a fuse rating where the fuse was okay but the equipment failed. Now that is not a very sensible thing to do. It sounds funny, but I can assure you that these things have happened in my experience. And because the criteria is different when you are actually on site and you are not able to switch off something, and you try your best to maintain an uptime despite all the other technical logic that is well known to other people. So periodic reviews and corrective actions are necessary. Otherwise, the investment that is made in power quality solutions will go waste, and will go waste pretty soon. So in order to ensure that there is a healthy return on the investment and the investment meets its objectives, step number 4 is a very critical part of the whole process. With this, I conclude my presentation, and I hand it over back to the organizers. Manas, over to you. Thank you very much for patiently listening. If I have made any mistakes, please excuse me.
Thank you, both Mr. Sharaf and Mr. Wajid. Mr. Participants, I would request you, if you have any queries, kindly put it into the chat box. And while addressing your question, probably you can mention to whom you are addressing this question in a short manner. In the meanwhile, we have got the first question. This is addressed to Mr. Sharaf. Sharaf sir, the question is, can you please elaborate on OPEX-based revenue sharing model as part of ARR regulation? Mr. Sharaf?
Yeah.
Please.
See, as of today, all the ARR are basically based on the capex. Now, I mean OPEX based ARR model and OPEX revenue sharing with OEMs means, let us say, if we are implementing BMS, or if we implement, say, APQI or any other automation need for the purpose of automation and monitoring and control of the network, then there is a capex involved. And after implementation of this, whatever are the benefits, let us say reduction into the loss, improvement in the power quality, improvement into the profitability, if that parameter, if we can identify and do the revenue sharing, then it can become a win-win situation, because that will ensure that whatever equipments are supplied by the OEMs, whatever investment the utility has made, both are working towards meeting the desired objective, and investment doesn't go haywire, and ultimately customer overall get benefited. Like revenue sharing formula, the way it is working in telecom sector, where the spectrum is revenue sharing. The same way, this type of model can be thought of.
Okay, great. So as a consequence, there is another question, again addressed for you. What role does investment analysis allow make more cost-effective decisions to mitigate power quality issues by Indian utilities?
I did not get the question.
Can you look at what role does investment analysis allow make more cost-effective decisions to mitigate power quality issues by Indian utilities? In simplified terms, basically it is asking that for mitigating power quality issues, what kind of investment analysis currently is carried out by Indian utilities?
Okay. See, Indian utility, when you try to
Discourse.
look at the quality. Hello, is it audible?
Yes.
Yeah. So whenever we try to make any investment, we need to look at what is the cost benefit analysis. Now, if we talk about quality terminology particularly, let us say there is a forging industry. There is a industry which makes computer parts or multiple mechanical parts. Now, if there is a power surge, or if the quality of the power is not okay, entire batch will go haywire. Entire batch has to be rejected. So if you consider the cost of the poor quality in terms of the customer, and then try to correlate with the investment required, if we required, we can always talk of premium for those type of support services or better quality, and then look at the investment analysis. So that is one of the example. Second is, if because of the quality, power interruption is happening in the area which are more revenue generating. Now, in that area, if the power quality is not good, then we are losing the revenue. Now, if we look at SAIDI, SAIFI parameters and try to see if my power quality is not okay for that particular customer segment or that particular industry segment, then how do I improve it so that my customer doesn't get distorted power, at the same time he doesn't get the interruption in the power, and I do not lose the business, because once he is not getting the power, he is not getting electricity, naturally it is a loss of a business. So these are the two type of analysis which investor analysis should do.
Great. I think that first portion of your answer also covers the collateral damage, what Mr. Mustafa has covered in his presentation. So
Right.
one needs to look at this that it is not purely from return, also from the insurance point of view. one need to look at a holistic approach. So thank you, sir. The third question now, this is addressed to Mr. Mustafa. Based on your experience, in what scenarios is the business case for reactive power compensation favorable? And the second part of the question, what about dynamic reactive power compensation like STATCOMs and active harmonic filters? Is the utility tariff regime helping such a business case?
Let me address that in two parts. Am I audible?
Yes, sir. Yes.
Yeah, the reactive power compensation fundamentally is more to improve the power factor of the installation that we are talking about. And there are different ways of doing it. And you can have a combination of fixed capacitors, you can have automatic power factor correction, and so on. The only care that has to be taken while doing reactive power compensation is to ensure that you don't land up with a scenario where you have an amplification of harmonics. And this can happen very easily because the harmonic flow is always from the load towards the supply source. And if the impedance of the capacitors installed is low enough when compared to the grid impedance or source impedance, it is possible that more harmonic will flow into the capacitor banks than towards the source. So typically the solution for that is to use detuning reactors in series with capacitors and ensure that you don't create a harmonic amplification scenario. The other problem is that when you are doing reactive power compensation in Indian networks, particularly installations in India, is that many times you operate the installation on a captive diesel generating set. Now the source impedance of the alternator is much higher than the source impedance of the grid plus the transformer. So what happens is that when you operate on the DG set, the same harmonic currents will give you higher harmonic voltage distortion because the source impedance has gone up. Now this can create multiple complications. So we have to be careful that we balance the design in such a way that it can work well under grid conditions and also not create problems when there is a diesel generating set powering the installation. With regard to the use of dynamic compensation, the dynamic compensation is normally recommended in 2 or 3 different scenarios. One is when you have a very rapidly fluctuating load. Typical examples are welding in automobile plants. That's a very classic example where just for about maybe 30 or 50 milliseconds, you have got the load and then you have got a gap. And during that 50 milliseconds, you have got a very large amount of reactive power flow. So to follow the load, I need a switching system which can act very fast, and therefore thyristor switching or other forms of dynamic compensation can be adopted. With regard to active filters, it is possible that your harmonic distortion voltage requirements and current requirements need not necessarily be fulfilled by using reactive power compensation banks with detuned filters. In which case, you will still have a leftover harmonic distortion which you need to reduce. And this is possible to be done by using active filters at different points in the buses of the installation and mitigating this problem by cancelling out certain harmonic currents. A certain amount of system analysis is needed for this, and it can also be a very good solution for reducing the harmonic currents and thereby reducing the harmonic voltage distortion. Coming to issues like STATCOM, STATCOM is typically used when you need to compensate unsymmetrically. That means that I have different currents flowing in the different phases which are not equal, and thereby the reactive power requirements in the different phases is different. So I need asymmetrical compensation in 3 different lines, and that is when that is not possible by any impedance-based system like capacitors or with reactors and so on. That is when I use electronic VAR compensation, which is also built in as a feature in active filtering. It can do both. Certain proportion of the equipment can be designed for doing reactive power compensation, and certain proportion can be designed for doing active harmonic filtering. Typically, STATCOMs are also used in very large steel plants and very large industrial facilities as well as with very large renewable energy plants because of a variety of unstable conditions. They are also used by power grid now on the, or they will be used in the next 1 year by power grid on the transmission system on the 400 kV network. So the use of STATCOMs extends all the way from transmission system application to distribution system application right into your installation. Typically, the STATCOMs used inside an installation are low voltage STATCOMs, and yes, it's a good solution, but please do remember it's very expensive. The other advantage with the STATCOM is that you can also compensate not only the capacitive compensation, but you can also do inductive compensation, and you can do it simultaneously. One line can be compensated in an inductive mode, whereas another line can be compensated in a capacitive mode. I'm not sure whether this answers all the questions that the person had in mind, but over to you.
Okay, there was just one left over, that was, is the utility tariff regime helping such a business case? I think I must answer this. The utility tariffs across India, especially the commercial tariff and the industrial tariff, is much more than the average cost of supply, because we have not really overcome the cost subsidy element, and it is only increasing day by day. With that high tariff of 6 rupees plus per unit for industrial and commercial, this kind of investment really makes a sense when one does the investment analysis. With that, the next question to Mr. Mustafa again. Can you give specific relevant applications with good payback that Indian industries could adopt for high power quality? Now, before I hand over to Mustafa ji, I want to just mention here that I would also request the participant, especially the person who has raised this question, to go to the case study section of APQI website, and you will be seeing number of industries, especially steel, hospital, process industry, automobile industry. There are fantastic case studies which are developed with the help of the industry by themselves, and you will have an insight. So over to Mustafa ji for answering this question.
Yeah, Manas, can you please repeat the question once again?
He is looking for specific relevant applications with good payback that Indian industries could adopt for high power quality.
Yeah, as far as there are three different dimensions to this. As far as power factor is concerned, most Indian utilities have minimum limits below which they penalize, and many of them have incentives for high PF. So a good example would be any industry which is trying to achieve a good incentive by maintaining high power factor without creating more problems on the harmonic side. There are many cases, like Manas has mentioned. This is across industries. It could be steel, it could be light engineering, it could be cement, it could be process industries, and so on and so forth. It is also true in the case of building loads, and that is something that is also very possible to get, and particularly in the context of the higher tariff that building or commercial buildings pay to the utilities. The case for reducing harmonic distortion by using active filters, etc., will automatically be good in an installation where there is very high percentage of non-linear load, and the higher the percentage of non-linear load, the greater the harmonic feedback, and once the harmonic feedback is greater, the voltage goes up significantly. So the use of active filters to mitigate this problem and reduce the harmonic distortion will be a very interesting payback calculation by itself, provided you consider the ill effects of the harmonics. For example, let us say we have more of the fifth harmonic, and the fifth harmonic happens to be a negative sequence harmonic. If I have more of the fifth harmonic in a network, all my motors will work at substantially reduced efficiency. So if I reduce the fifth harmonic, my motor efficiencies will improve dramatically, and therefore my energy consumption of that motor will come down for the same performance. this is a very neglected topic because most of the time we are treating harmonics as one family, which they are not. Just like how you have triplen harmonic, you have positive sequence harmonics, you have negative sequence harmonics. The fifth harmonic happens to be negative sequence and is very popularly present in most networks. And this can reduce efficiencies of rotating machines by as high as 20 to 30%, depending on the level of its presence. So mitigation of harmonics at one level from an economic point of view will improve efficiency and reduce losses within the network. Another important issue is that if you have too much of distortion, your protection systems, digital relays, etc., semiconductor devices, because you may be using drives, you may be using UPS systems, you may be using various types of semiconductor operated equipment. It is quite possible that because of high harmonic distortion, the true zero crossover of the sine wave is no longer achieved as a true zero crossover. And if that happens, there can be failure of semiconductors inside the power electronic equipment. So one has to be very careful because semiconductor devices are very expensive and they call for long downtime to replace and so on and so forth. So it's actually a combination of economics, compliance, and collateral damage. So these are cases, look for cases where there is very low power factor being achieved. Look for cases where there is high nonlinear load content, and automatically you have a candidate for a good payback period in power quality investment.
Great.
Over to Manas.
Thank you, sir. The next question comes to Mr. Saraf. Are there any plans to implement a PQMS, power quality monitoring systems, like the PQ View in future, as these are known to be very effective way in long term to understand the distribution network?
Yeah,
Mr.
we have a
Saraf?
plan to implement this, and we have already implemented the similar system in our specific areas like Bandra Kurla complex, and then NSE. So the areas where we have got premium customers, we have already implemented, and depending upon the customer profile and requirement, we have planned to implement it.
Great. Thank you. This question goes to Mr. Mustafa. Any survey has been done in any industry sector to find economic losses due to power quality issues like voltage sags, swells, SAT, and long interruptions, etc.?
Voltage sag and swell is a very peculiar phenomena which arises due to two reasons, and the primary reason will be the type of loads that you use in your installation. I gave the example earlier of the welding loads in the automobile plants. Now, in our experience, we have seen that any attempt to operate such loads on a diesel generator set powered network invariably will lead to significant voltage dips because of high source impedance of the diesel generator. Now, these are cases where this can be a very peculiar phenomena which happens. Similarly, voltage flicker is another problem that can arise because of very high speed operation of things like power presses and so on and so forth. And that's a matter which again needs to be mitigated slightly differently. With regard to voltage swell, typically that happens only when you get it from the supply system side. It is very difficult to create a voltage swell within an installation. It will require some highly abnormal conditions to arise, which are very rare. I mean, I would not worry about that too much in practical terms. With regard to an industry survey, unfortunately, I don't think it's been documented very well. But in my experience, in our organization, we had documented this, and we had kept it as a reference guide for all my colleagues to follow whenever they were pursuing a particular type of job or a particular type of application. But I don't think there's a published document which is available in the public domain which gives out a very holistic survey of these type of scenarios. Over to Manas.
Okay, just to supplement, I think there are two documents which can be referred to for this kind of survey. One global document is the Leonardo Power Quality Survey, which was done over a period of 2 years. What is the economic impact on varieties of industries and due to varieties of power quality issues? So incident wise, that document is a published document which you can see even in APQI website. The second one is the loss to digital economy, a survey which was conducted by APQI US. If you go to APQI site, you will be getting that kind of document, but that was mostly addressed for digital driven industries. Besides that, in APQI, along with IIT Delhi, we tried to conduct a survey on this aspect. But as Mr. Wazid mentioned, that in India, we could not gather very consolidated information maintained by industry. It is more fragmented. And there is some effort which is going on this area. So with that, we move to the next question. The next question again to Saraf sir.
Yeah.
When do you see utility meters becoming consumer centric, such that the customers can see their consumption, power quality, etc.? How is the utility tariff regime responding to power quality issues? What is the extent of practical control that the utilities can keep on EHDV? I think there are multiple questions in this. Number one, when do you
Yeah.
see utility meters becoming consumer centric so that customers can see their consumption, power quality, etc.?
Okay. See, the currently the private utilities like Reliance or Tata's or CSUC, they all are moving towards implementation of the smart metering, or we call it EMI. And once and the purpose of implementing the smart metering and AMI is to involve the customer. Customer should know what is his current consumption, what type of load he is getting, what type of quality he is getting, everything related to his consumption, rather than getting a a bill at the end of the month or at the end of the usage. So there are a lot of initiative in this direction, and the days are not far away. It should happen in next 1 or 2 years maximum. People will start seeing this getting adapted. Uh, People are working on the technology part, how the communication technology will be leveraged to take care of the communication and the real time getting the data to the server and managing the big data analytics and all. A lot of work is happening on that direction. On the utility fronts, so far as our government distribution companies are concerned, they have implemented AMR, automatic meter reading, at the distribution transformer level, but they have not yet gone to the consumer level. They have just gone till the HT customer level. They also have planned to implement the similar things, but it being government, it will be driven by their own processes and policies. But in India, at least wherever the private utilities are there, like Torrent or Reliance or Kolkata Electric or RPG, you will see that it is getting implemented in the near future.
Okay, just to supplement the HT industrial customers or EHV industrial customers who are having ABT tariff, who are subjected to ABT tariff regime, they are already able to see their consumption, power quality, etc. But for the others in the HV customers or MB customers, it is going to come as Mr. Sharaf had mentioned. Sarabji, the next question is, how is the utility tariff regime responding to power quality issues, and what is the extent of practical control that utilities can keep on voltage distortion?
No, that I
Mr.
think,
Saraf?
yeah, discussion is going on this, because now there is one more regulation which has come up. The consumer will be also in producing. That means they also will be adding the power to the grid. So there are a lot of complication in terms of power quality. So consultation is going on this, uh, and based on that, the decision will be coming. But yes, this is going to become a challenging factor going forward, because it will not be only responsibility of the uh, grid or the distribution, because the customer also will be putting the energy into the grid. So that way the issue is going to be addressed. Does it
Okay,
answer
I
the
think we
question?
have. I think it is sufficient, and when we host it on the APQ portion post the webinar, we'll little bit more elaborate with your help. So that should help.
Yeah.
I think we have a few more questions, and we'll take two more questions because of our time limit for the webinar platform. And rest of the questions we would put it into the FAQ block when post-webinar posting on the webinar site will be done. So this question, before the last question, which we will take it online, Mr. Sarab, any quantification that comes to your mind on customer losses on account of poor power quality?
I didn't get it. Can you
The
repeat it?
question is, any quantification that comes to your mind on customer losses on account of poor power quality?
Customer losses.
Yeah.
See, as of today, the customer losses because of poor quality, there are n number of cases, because many customer has lost lot of revenue, lot of profitability, lot of batches of the production because of poor quality. Not in Bombay, but out of Bombay
But
also.
he's
There are
trying,
innumerable cases. Hello?
he's trying to know whether he's trying to know whether utility has made any effort to quantify such losses.
No, no, not yet. Not
Okay,
yet.
I
But
think that will be a good idea if we can, gather information like management information system, so that along with the customers, the utility can take win-win approach, which
right,
you have mentioned earlier.
right.
Okay, so we move to the next and last question. It is for Mustafa ji. Any change in business models for power quality correction in India? For example, the equipment devices like welding manufacturer will start hosting PQ correction during installation and covers as part of equipment cost and installation.
Could you please repeat that, Manas?
This is very interesting. Thought process. The participant is asking that is there any change or any change you see in business models for power quality correction in India? So he's giving an example. Suppose a welding manufacturer is putting installation. He will
Yeah.
also host the power quality correction during the installation and cover that as part of the equipment cost and installation.
Yeah, I mean,
So
if
his
I
question is
see it
any
as a,
change, something like that.
yeah, can I respond to that? No, there is a complexity in that
Yeah,
which one should
please,
understand. For
please.
example, if I have, let us say, 30 welding machines installed in a plant, it is quite possible that out of those 30, at any given point of time, only 12 or 15 are working. So it becomes very inefficient in a cost sense to ensure that every welding transformer is appropriately compensated for a voltage dip situation. Okay, so typically what customers prefer is to do the power quality correction or power quality management a little upstream from the load, because then you get the benefit of doing it across the actual operation and not across every equipment. Which means that the capex cost will unnecessarily go up. So one of the reasons why equipment based power quality correction is not done as a standard measure is because it can inflate the capex of the equipment without necessarily delivering the full benefit to the user.
Thank you. I think with that, we will draw close for today's webinar. I take this opportunity on behalf of all the participants and APQI community to thank our experts for having spared their valuable time and share their thoughts. We look forward to be in touch, and please do visit APQI website post webinar. We will be posting the presentations as well as the question answers in a tabulated format. Look at the case studies, look at the application notes, which we believe will benefit. And if you have some interesting cases which you would like to share, please do come in touch with us so that the community can benefit at large. With that, I thank you all once again for having participated and being a lively audience. We wish you a very good evening. Thank you.
Thank you. Thank you.
Thank you very much.